Give me one quick second here. All right, yeah, sorry about that. Now, hematocrit. Let's start there. So one of the things that what you'll get tested when you do a blood test is your hematocrit level. What they're actually looking at here is essentially the ratio of the volume of blood cells you have to the volume of total blood, right? So if they extract a mil of blood from you, that mil of blood is supposed to have somewhere in the region of 45 to 50% red blood cells, and the rest should be plasma. Now, the hematocrit allows you to quickly see if a patient's blood count is too low or too high, right? Because too high can also be a problem. If you think about it, too low, of course, means you don't have enough red blood cells. So your ability to carry oxygen is going to be severely limited. But if you have too many red blood cells, it makes your blood hard to pump because the blood is too thick, which of course can put a strain on your heart, strain on your blood vessels, and leave you at risk of strokes and heart attacks and stuff like that, right? So not enough blood and too much blood are both bad, right? Now, this says here, the percentage of whole blood volume contributed by the form elements, right? So, of course, that of course is the red blood cells, the white blood cells, and the platelets. That is what makes up, or as we said, the form elements. So please don't forget that, right? Now, obviously, the vast majority of cells you'll get from hematocrit are going to be the red blood cells, since the bulk of cells in the blood, of course, are the red ones, right? Now, it mentions here that an adult male has a hematocrit level around 46%. As I said, can vary between 46 up to near 50%, right? So adult male, somewhere between 46% and 50% of the blood should be cells. Female is a little lower. And we spoke about why females would have a lower blood count than males before, right? Remember, muscle mass, right? So now this is just showing you very visually how easy it would be for you as a nurse to take out some blood from a patient, centrifuge that blood, and then just look at the test tube, and you'd be able to tell what is going on to some extent with the patient, right? So you can see in the first slide here, this is a normal hematocrit. The red part comes almost to the middle of the sample. And the rest, of course, is a straw-colored plasma. Remember, this is plasma. It's not serum. Don't forget the difference, right? Over here now, you can see that this person has a hematocrit level that is somewhere in the 30% range. So you can say that this person has fairly severe anemia, right? No other, so it's a simple test, some blood, and a centrifuge, and you're already making conclusions, right? Now, this other person here, you notice that their hematocrit level is near 70%, right? Which gives you a condition called polycythemia. You have too much blood, red blood cells, or blood cells in your blood. And remember what I said to you, this makes it very, very hard to pump that blood. Stroke, heart attack, there are other conditions as well, all of which are going to be caused by too many red blood cells. Also, is that this is potentially a sign of cancer, right? Several types of leukemia can cause this massive increase in blood cell count. So if somebody is polycythemic and there's no good reason for it, a bad reason, because of the outcome, of course, might be cancer, right? And then now, if you look here, this person here is suffering from dehydration. Now, how do we know they're suffering from dehydration? Because if you notice here, the plasma volume is low, right? Coming at it. So they have the appropriate amount of red blood cells. You can see down here, it's about 45%. So that's normal, but the level of plasma is way down. So this person here is becoming dehydrated. All right, let me ask, Alicia, ask the question and then I'll get to your question, Alian.
Oh, so I was just asking if you could put the slide on full screen.
Oh, sorry.
Yeah.
All right, there you go. Right. What causes that? Can you be more specific, Alan, what we're talking about when we say that? Just type it in the chat. What do you mean by that? All right, I'll leave you to get around to that one. All right, so I'll check back in on the chat in a little bit. All right, so as I said, just by being able to just look at the blood. Hold on, is HBP supposed to be high blood pressure? If HBP is high blood pressure, then polycythemia will also lead to high blood pressure. So you're correct about that, right? Whoever iPhone 2 is, your mic is on. Please turn it off. And in the future, when you come to an online lab, you're supposed to have your name, not the name of your device, okay? Because this is how I take register. So iPhone 2 is not registered to the class, right? Anyway, let's continue. Oh, you know, I forgot to turn my camera on too. I need to keep my camera on for the couple of classes so that when you see me, you know me. Then again, I'm hard to miss. All right, let's continue. Chantel, you have a question?
Yes, sir. Can you hear me?
Yes.
Sir, so every time that I go to give blood, they would take a sample and
Correct.
not necessarily draw the blood. What is the cause for that?
Well, first of all, in order for you to give blood, you have to have a blood cell count what's it? I think it's 11 I think it's 11 millimoles per microliter or something like that. So what they do is they take a drop of your blood, they put it on a slide. Well, it's not a slide, it's a special slide for counting blood cells, right? So the slide itself has like a grid on it. And what they'll do is they'll count the number of red blood cells on several grids to get an average, right? And by determining that average, they can say, boy, your blood cell count is low, higher, or just normal. And from that, they can say, no, you can't give blood, or yes, you can give blood, right? They also take a sample of that blood and they do testing for like STDs and other things later on as well.
Okay, sir.
But that's one of the first things they do. They test to make sure that you can give blood, because if you try to give blood and your blood cell count is very low, they could cause you to have a heart attack. So they have to be very, very careful.
Okay, sir. Thank you.
Yeah, man. All right. Any other questions? Thought I saw somebody come and go. I could be wrong. All right, let's keep going. So we spoke before about the shape of your blood cell and why the shape of the blood cell is so important, right? Now, this biconcave disc that you've heard about all of your life is very unique and very specific to your red blood cells. You're not going to find any other blood cell with this shape, right? Now, let me see if I can do something in this little corner here, so. Oops. All right, let's say that I'm drawing a capillary here. Let's go. All right. Now let's say that this hold on one second, I'm having an issue with my mouse here. Let's pretend that this is a lovely red blood cell. Okay. Now this red blood cell wants to travel down this capillary. Now, because of the shape of the red blood cell, when the blood cells are traveling down narrow capillaries, they don't just go one at a time. Instead, what they do is they form stacks. So one blood cell will attach to another one like that, and another. Right? And they will travel down the capillaries, which are very tight, as you can see, in stacks like this. And by traveling in these stacks, they move more efficiently and you move blood more easily through very narrow capillaries. So that is one of the reasons why you have this biconcave disc shape, right? That allows for this transfer, this movement. Now the stacks themselves have a special name. And it's called a rouleau. All right. So it's a rouleau. It's a French word. That's why the AUX is silent, right? So other blood cells can't do this, right? It's more efficient. The other reason for the biconcave disc is this. It makes the cells more flexible so they can twist as well, a little bit, to squeeze in through very tight corridors, right? Also, the middle of the little donut, there's the depression here, right? This little point here, which is normally, as it says here, 0.45 to 1.1 micrometers thick, is an easy way for oxygen to move into the red blood cell, right? So this is where you load up. So because it's very, very thin, it means there's a large surface area to volume ratio. So oxygen readily goes into the blood cells in the thinner part and spreads out through the rest of the blood cell. When oxygen wants to leave, of course, it also makes it easier for the oxygen to leave by having this little thin depression in the middle, right? So that explains, hopefully, the shape of your red blood cell, why it has to be that way. Now, one issue that in Jamaica, you all know that we have people with sickle cell. One issue that sickle cell has, of course, first of all, when you hear the word sickle cell, you assume that the cells are, sort of sickle shaped. That is not fully true. Some of them are that shape, but you have lots of cells that are simply other distorted shapes, right? Now, when you have sickle cell and those distorted shapes get to a narrow capillary, they cannot form a rouleau, right? Which means transporting these cells is much less efficient, right? They're bundled up and they're banging into one another, but they won't stick to each other to form that little stack. Not only that, it's possible for them to actually jam up the capillaries. They get stuck in there. and then blood pressure has to force them out, which of course slows down the movement of blood to a person who has sickle cell's muscles and tissues. And this is one of the things that causes the symptoms of anemia. They're not able to move these messed up cells to their extremities, their fingers and toes. And you talk to somebody with sickle cell, they tell you about they get tingles in the fingers and toes all the time. And sometimes they get muscle aches. And one of the reasons why the muscle aches is low oxygen levels, because the blood is not able to flow smoothly through the capillaries because they can't form the lovely rollus, right? So I don't know if you know anybody with sickle cell, but this is something that happens in them. Penado, go ahead.
Sir, could you please repeat what you had mentioned about the Rolex? I got bumped off the internet.
Hold on. What I said about the who?
The Rolex, what you have written on the screen.
This is Roleo, not Rolex.
Oh, sorry, that word.
That's okay. It's a new word, right? So remember, this is pronounced, this is EAU is pronounced as. So Roleo. Because remember, it's a French word, it's not English, right? So the Roleo is the stack that the red blood cells can form. So this stack here is a Roleo, which allows them to move quickly and efficiently through capillaries. We're mentioning that when somebody has sickle cell anemia, the malformation of the cells prevents the proper formation of Roleus, which means it takes longer for these malformed cells to pass through capillaries. Therefore, of course, they deliver less oxygen per time. So you'll find a person with sickle cell, of course, is going to have low oxygen in their extremities in particular, as well as in other tissues, which of course causes pain and tingling in their body. That's what we're saying, right? All right. Now, in terms of the diameters here, so we have the thickest portion of the red blood cell being approximately 2 micrometers thick. We mentioned the central region already, half a micrometer to around 1 micrometer thick. And the whole overall, now, the size of the red blood cell, it ranges a little bit. They're not all going to be exactly the same size, but they're somewhere between 7 and 8.5 micrometers thick, wide, right? Now, obviously, if you remember what I have here on the slide, you're perfectly fine, right? Now, we already spoke about the features, so I won't bother going into that again. But just to remind everybody, red blood cells are very similar in some ways to a bacteria. And the similarity comes from this. They do not have membrane-bound organelles. By that I mean, there's no nucleus in them, there's no endoplasmic reticulum in them, there's no Golgi in them, right? So remember those things from when you were doing cells, right? The reason why these cells do not have any of these things, or mitochondria either, is to have space to stuff all the hemoglobin, right? So you've taken out the majority of what makes a eukaryotic cell in order to have space to stuff hemoglobin. Remember, the red blood cell started out with all these things. It started with, right, your pro-erythroblast would have had all of these things. But as the cell developed into a red blood cell, it had to lose all of them so that you could pack it with hemoglobin, right? Therefore, red blood cells are still eukaryotic cells, right? Just that they start out that way, just that they get modified later on, right? Now, obviously, your red blood cell has a large surface area to volume ratio. We already spoke about that, right? Which is what allows the load. Remember, the central part is thinner and wide, so it easily loads oxygen or carbon dioxide and can easily release them as well, right? And here are our lovely Roleus. You can see them here. So they should look like stacks. So look at this big old stack, look like a snake. All right? And because they're piling up on one another, like you're piling a tower of coins, they can rush through the capillaries much more quickly. Right? Don't forget, sickle cell, this is a problem which reduces the rate of blood flow, right? In capillaries. And we mentioned the flexibility already. So they can squeeze through narrow capillaries to get where they're going, right? And we mentioned the lack of organelles, right? So now you know the major characteristics of your normal red blood cell, right? That said, let's talk about blood type real quick. Now, I'm assuming everybody knows the concept of blood type already. Most people have what we call the ABO blood system, right? I'm sure you've all heard of ABO, right? ABO.
Yes, sir.
Which basically means you can have blood type. You can have blood type that is A, you can have blood type that is AB, or blood type B, or blood type O, right? So those are the major blood types that you can have. Now, they can be positive or negative, but we'll talk about what makes them positive or negative in a little bit. First, let's talk about what makes a blood type A, B, or O. Now, have you guys heard the term antigen? You said you heard you know the term antibody last time, but have you heard antigen?
Yes.
Zanel, my blood type is AB, and we're going to talk about it in a little bit. All right, so everybody should know that an antigen is essentially a protein. It's almost always a protein that usually sits on the surface of a cell, and this antigen can trigger an immune system, right? So essentially, the antigen is a protein that an immune system cell can recognize, okay? It sees it, it knows, well, it knows one thing. It knows either this thing here belongs in me, in the body, or it doesn't belong in the body. That is how your immune system determines what to attack. So because of that, now we end up with two types of antigen. One of them is called a self-antigen. All right? And no surprise, the other one is called non-self. Seems stupid, but you know, and I didn't make up the term. All right? So here's how this goes now. All your body cells have antigens on them, hundreds of different types of antigens, right? The ones that are in your body, your immune system knows them, has a record of them, knows that they belong inside you. Okay? In addition to the normal hundreds of antigens that your normal cells have, your red blood cells also have 3 unique ones, right? That is antigen A, which of course makes your blood type A. Antigen B, which can make your blood type B, as well as what we call the rhesus antigen, the RH. This is what makes your blood positive or negative, okay? Now, these blood antigens are important because they can cause extreme immune system reactions, right? They're not the only ones that can cause the reactions, but they cause the most extreme reaction. So because of that now, if you are a blood type A and you give that blood to somebody who's blood type B, you're gonna have a problem. Why is that? Because when the immune cell comes along, this is the antigen thing we're just talking about. It just mentions here the antigens are made of what it says there, they're integral membrane glycoproteins or glycolipids, right? So there are no glycoproteins or glycolipids, mostly glycoproteins. So you can see them here sticking off of the cell surface. membrane, right? So your immune system cells will come along and they will check the surface of the cells. And if there are any antigens there that your immune system does not recognize, it is going to go into a frenzy. And your immune system has two modes. Mode 1, it leaves things alone. It doesn't know anything. Mode 2, it tries to kill it. So once again, if your blood type is A and somebody else's blood type is B, and you donate blood to them, blood type A in you is perfectly fine. Your immune system knows A. It's happy to have A around. It doesn't care. The other person's blood type is B. It don't know nothing about A. So when you give that person now whose blood type is B, some of your A blood, it is going to cause problems because their immune system is going to check the blood cell and say, what is this? What is this A business? Kill it. Right? And that, of course, is what causes a blood transfusion reaction. It is not that there's something wrong with the blood. Keep it in mind. It's just that your immune system doesn't recognize the antigen on it and therefore will try to destroy it. If it wasn't for that, the blood would be perfectly happy in the body and it wouldn't make a difference, right? So, of course, the rhesus antigen makes the blood positive or negative, right? This is another one. So if you're a person whose blood is B again, but they don't have the rhesus antigen, they are B negative, right? Now, negative blood is a little bit of a problem, right? Negative blood is a bit of a problem. Let me tell you why negative blood is a bit of a problem. When you do not have the rhesus antigen, you will react badly to any blood that has it, right? So for example, if your blood type is B negative, and they try to give you blood from somebody who is B positive, that is not going to work. Because even though you are B and the blood is B, once again, your immune system comes along and says, checks the blood and says, oh, I see B there. Hi, B, how you doing? Everything good? And I say, yes, everything good. And then I walk over to RH and say, who is you? Antigen, who you be? And even though they recognize B, they don't recognize positive. So they're going to attack it again. And that can, of course, kill you, right? But the other way around now is different. If your blood type is positive, right? So if you are B positive, and then you are given blood from somebody who's B negative, all is well. Why? Because there's nothing there to respond to, right? If there's, right, so if the blood is negative, it means it's missing something. And your immune system can't respond to something that is not there. So positive blood can get negative of that same type, but negative blood cannot get positive. Please keep that in mind, right? I don't know how many of you know your blood type. We'll figure it out eventually, right? Now, there are other blood typing systems besides ABO. And I'm going to mention them very briefly, right? But we're really going to get into the detail because 99% of the population is ABO blood type. Most of you will work your entire careers and come across somebody with a different blood type, right? So we have MNS and P and Rhesus and Lutheran and Kells and Lewis, right? They all have different antigens besides A, B, and of course the Rhesus, right? But we don't worry about them because ABO is what's important. What I will say is this. If you have one of these, right? When you do a blood test, your blood will come back as O negative. So if you have a different blood type from the ABO system, you tend to show up as O negative. But if you give that person O negative blood, it can kill them. But it is very, 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 very rare. So we're not really going to worry too much about it. 0.001%. Yeah, and some of them is like 1 in 10,000, 1 in
Sorry, you can repeat
50,000.
that, sir?
Which part?
About the O negative and not being a part of the ABO
Yeah,
system.
so if your blood system is one of these very, very rare types, you tend to show up as O negative when you do an ABO blood test. All right. But of course, if you get a O negative blood, it can kill you. But as I said, it's extremely rare. Testing indicated like 0.001%. I said 1 in 10,000, 1 in 50,000 is those are the kind of numbers. So most of you will spend your entire career and you will never come across somebody with one of them. Right? All right. We already spoke about A and B antigens, right? And the importance, right? Now, let's talk about somebody with blood type AB. Obviously, if you have blood type A, you have A antigen on your blood cells. If you have blood type B, you have B antigen on your blood cells. But if you are blood type AB like myself, and there was another student, I think, you have both, right? Now, if you have neither, you are going to be blood type O, okay? Now, remember how the O thing go. If you have the rhesus antigen with the O, you are O positive. If you have the rhesus antigen with the AB, you're AB positive, right? So positive, remember, indicates that you have the antigen. That said, you must have heard of universal donor and universal recipient, right? If your blood type is AB positive, and the positive is important, you are the universal recipient. So my blood type is AB positive. What does that mean for me? It means if I drop down a road, any random person can give me blood and I can accept it, right? Anybody in ABO system can give me blood. So, Zanel, congratulations. You don't have to worry about there being a blood shortage if anything happened to you. Because anybody can give you, as long as you're AB positive. But remember, if you're AB negative, it means you can't get blood from anybody who is positive. That is now when you have a problem. And I'll talk about that in a second. Now, the other extreme of this is going to be O negative. And O negative is the universal donor, right? If you're O negative, you can give blood to anybody at all in the ABO system, and it won't do them anything. So if you're a giving person, it's the perfect blood type for you. That means I'll keep AB positive. But here's the thing. Because you can give to everybody, you can only get from O negative as well. So O negative blood is not great if you've been in an accident, right? So if you have O negative blood type, try walk through life very careful. Because I can tell you one thing, there is rarely any O negative blood at the blood banks in Jamaica. It gets used up very, very fast. And if you go to the hospital and you're in desperate need of O neg blood, dog name is over. Right? I don't have a problem. I can't take anything. You have a problem. Right? Now think about this as well. So AB positive can get blood from everybody. So A positive, no problem. B positive, all is well. O positive, great. And of course, AB positive like themselves. Right? And it can get blood from the negatives too. So A negative, B negative.
Yes, sir, question.
Go ahead.
Since the O negative can give everyone blood and can only receive it from
negative plus, just in case there's an emergency.
Only O negative.
What about the O positive, sir? Who
Well, O
that,
positive is not quite as bad
um,
because O positive can get from O negative and O positive, right? So O negative can only get O negative blood, right? But in
So O
Jamaica,
can only get from an O.
no, hold on, be careful and remember, O negative can only get O negative. If you're O positive, you can get O negative. You can also get O positive.
Oh, okay, sir.
Remember, positives can get negatives, but negatives cannot get the positive. Now, the good thing about this is that the bulk of Jamaican blood type, I think it's about 46, 47%, are O positive. So if your blood type is O positive, it still means almost half the population can potentially donate blood to you. Right? So, I mean, if you're going to be O, better have to be positive than negative, right? Now, when you put in the wrong blood type, this is what happens. It's called an agglutination reaction. So basically, the person's body makes antibodies against the blood and causes the blood to clump up. All right? When clumping is caused by antibodies, it is an agglutination. It is not, you can't just say coagulation. It is agglutination, right? So that is clumping up caused by antibodies. And you end up with these big, massive blood clots in the blood and blocks your blood vessels and you drop down dead. Right? Or it can cause severe damage to areas of your body and you can lose function in your body parts. You can have organ failure, all kind of things. Right? Stroke, all kind of things. As a man, if you want to assassinate somebody and you happen to be a nurse and you happen to have the chart and the person have O negative, O positive blood, you just take a little pen and you do a little scribble and you turn O positive to B positive, and that's it for them. Right? Generally speaking, it's not going to be immediate, but within 12 hours, they start to feel symptoms. And generally speaking, within 15 hours, more often than not, they're in severe distress or have lost consciousness entirely. And usually within 24 hours, if they get enough, they're dead. Right? And of course, if you as a doctor don't know what you're looking for, the time it takes you to figure it out, they're usually dead. Right? Now, that said, this also shows you here where hemolysis has occurred. Basically, the blood cells have been blown open by antibodies produced by the person's blood. So in addition to clumping them up, you destroy them as well. And when you destroy the red blood cells, they dump all their contents into your bloodstream, which changes the osmotic concentration of your blood, and that in itself can cause all kind of problems, right? So getting the red blood type is bad, no matter how you do it, right? Now, hopefully next week, we'll go through and we'll find out what everybody's blood types are. Because there's another issue, right?
sir,
No, the black blood is something totally different. Yeah, come again.
question. Since you can get blood from anybody, you can give blood, sir. I don't know if you had mentioned.
No, remember now. If you can give to everybody, as in O negative, you can only get from O negative. Right? But if you can receive from everybody like me, I can only give back to AB positive. So I can only give to my own as an AB positive, and as an O negative, you can only get from your own. Because if my blood goes to anybody else, it's gonna cause a problem, right? So I can't give blood to any of my children. My children are B positive. Right? I can't give blood to my wife. There's nobody in my family I can give blood to. Right? It is what it is, right? But I can get blood from all of them, which is always nice. You know? I have lovely little bags of blood running around just in case I need it. Now, I was about to talk about now another issue. If this is not going to be for women. If you're a female and your blood type is negative, it's actually worse than if you're a male. Because of this condition here, erythroblastosis fetalis, right? Let's break down this lovely word here. One of my favorite words. Erythro, blast, of course, you're looking at blood cells, right? Blast, of course, referring to cells. And of course, blastosis. Oosis is a condition, right? In this case, it's destruction. And fetalis, fetus. Here's the thing. If you're a mother and you're negative and you get pregnant, from roughly around 94% of people in Jamaica are positive. So the vast majority of people walking around have positive blood. Which of course means, statistically speaking, the baby father, hopefully husband, is going to be positive as well. And if he's positive and you are negative, better chance than not, the baby will also be positive. Now, during the course of the pregnancy or during labor, right, there's going to be a significant chance of the blood of the baby and the mother coming into contact with one another, right? So, I don't know if, I think there are a couple of midwives in here. I said, Alian has displayed prominently her midwifery. Very proud of it. Good girl. Midwives are going to be exposed to the natural beauty of childbirth. And by natural beauty, I mean it's the most disgusting thing you'll ever come across. It is loud. It smells bad. There's poop and pee and blood and hollering and yeah, no thanks. Yeah, no thanks. Right? But don't forget all the ripping and tearing going on as that baby is coming out like a alien from an alien movie, tearing himself out. Right? So during all of this wonderful process, the mother's blood and the baby's blood are inevitably going to mix. So the mother gets exposed now to the positive blood. She's negative. So what does her body do? It starts to produce antibodies against the rhesus factor, against the positive, right? So now the next time she gets pregnant, she has Rh antibodies floating around in her blood, right? And these antibodies are small enough to go right across the placenta and go into the baby's bloodstream. And of course, when that happens, it agglutinates the baby's blood. Remember, agglutination is clumping caused by antibodies, and this will, of course, kill the baby. So the woman will get pregnant, she will have her baby, and then every time she gets pregnant after that, she has a miscarriage, one, and then the next, and the next, just one after the other. And she doesn't know why she keeps having miscarriages, right? And from that point on, she will have a hell of a time having another baby. So erythroblastosis fetalis, right? If the woman is very bad looking, she gets exposed to the baby's blood early in the pregnancy, and that causes her to have a miscarriage of even the first one. So she ends up with no babies, right? These days, of course, you can treat it. You can give the mother, it's called Rogam. And the midwives are going to get very, at least somewhat familiar with this stuff. So Rogam can be administered to the mother during the course of her pregnancy to reduce the chances of her having a miscarriage. The Rogam basically blocks the antibodies and prevents them from getting into the baby's blood. It's around 75–80% effective. So it's not perfect, right? But it helps. The problem is the stuff ain't cheap. I think it's what, near 100 grand for a dose or something like that. So if you have so if you have negative blood, your pregnancies might be more expensive than average. Oh, all right, it's 12:56. We're basically out of time. Any questions before we go? All right. So
Sir,
go
before you
ahead.
continue, how can you access these recordings?
I mean, I have no place to put them. Moodle won't take them in too big. And Schoology is shut down, so I'm not sure how I can manage that. But if y'all can figure something out, you can let me know.
Can you put it on a Google Drive?
Google Drive. All right. Send me a link to a Google Drive and I'll see what I can do with it. You're
Okay.
supposed to have, but remember, I can't just send it to one person. It has to be like the class.
We have a class
division.
email, so we can.
All right.
use
Well,
the-
y'all have my email, right? Email it. By the way, this is my fault. I admit it. I kind of lost the WhatsApp information because I should have taken it down out of the chat and it completely slipped me. So when you send me the Google stuff, send me the WhatsApp to them. All right. That said, I am hoping to be with you Tuesday. You know the saying, hope in one hand and something in the other, and we'll see what happens. Ranil, what was your question?
So you had said to send you the WhatsApp information, sir. We had created the group, so you're not seeing yourself in it.
No, I haven't even checked, so I don't know. I'm gonna be perfectly honest with you. I don't use WhatsApp. I don't like WhatsApp. I don't really, unless you tell me to look in there, I'm not gonna see it. So if you're trying to contact me via WhatsApp, I'll next year and before me see that. All right? Send me an email, call me. That's the only way you can get through to me. If you WhatsApp me, you're gonna call me and tell me say you send a WhatsApp. So what sense does that make? Right? But if I have the WhatsApp for the group and I need, then if I need to, I can reach out to you, right? So yeah, but
Yes,
send
sir.
send the Google stuff for me. All right. So
Um,
remember now, go ahead.
Alright, sorry. We are to have a tutorial prepared for next week Tuesday, right? Since you'll be coming.
Yeah, but remember I started I missed the class that we're supposed to have on Wednesday because I had a stupid meeting I was forced to go to. A complete waste of time. But 90% of meetings are, you'll find out that in your life. So I couldn't get home in time, right? So I missed that one. So what I want to do is, I think for the first tutorial, I'm hoping, crossing fingers that we'll be doing it in person, is that I will project the tutorial questions and we can run through them together in class with each other. Right? So I won't ask you to do those separately because I want to get another lecture under the belt so that we have covered all of blood before I give you a blood tutorial. So for next week, just read through the slides and come prepared. I'll be asking people questions, of course. Now, let's just say, for example, that I do not get a chance to go down to you because of the shenanigans. We're still going to be doing a tutorial, but we'll simply do it online. Did we make up our minds as to when we're doing the tutorials? It was I think it was immediately after class or so ago.